Hi, I'm Emarie,
And I'm John Edward.
and we're excited to get to do the Heads and Tails project for SkillsUSA.
So the first problem that we were faced when doing this project was we had to make a device that would efficiently and consistently flip a coin from heads to tails.
And so you might be wondering, how does this pertain to real life? Well, let's say you were a chemical engineer. You would have to be dealing with materials that could possibly be radioactive, acidic, toxic, and you wouldn't want to touch these. But let's say you have to move it from one container to another. You might need to make a device in order to move that material, but let's say this material is fragile, or let's say it can't be touched by human skin, or it can't be touched by certain materials, or it will disintegrate it. So you need to make a device in order to move this, and that will be a part of your daily job. So it's necessary to learn these skills in order to help in the workforce.
Now obviously this challenge has much less risks involved with it being a quarter, but the concept still stands. Our goal here was to make a device that would flip the coin efficiently and without much use of the user's finger, especially using only one extended finger as a limitation of the device itself. It also had limitations with material, with how much we could use, so it was a very small device that would have to be compact and efficient in its means. In the beginning, we decided that the most efficient way to do this would be to go with two separate designs to create a much more likely possibility that we would stumble upon a working design. So, in the beginning, I came up with the design that would rely much more on physics and natural means to move the coin. The idea would be that you would only have to apply a minimal amount of force to get the coin onto a device that would do the rest for itself.
I took a little bit different approach. My first thought was gravity, and I thought of carnival rides that you see at any fair, an everyday thing. And I thought of, though they are mechanical to an extent, most of the time they use weight to help spin them. And then I thought of a gyroscope, which also uses the same momentum in order to flip something or to stabilize something. And so I wanted to use the physics of weight displacement as seen by the scale and use that in order to flip my device.
So, in the beginning, we decided to start with my design to see how that would work out. And as you can see here, I made some starting sketches that would illustrate my point. With these early designs, I knew I wanted to have some kind of ramp that would allow the coin to slide off onto the podium. Each of these designs has a ramp like that. However, most of them suffer from either being too complicated or having too many mechanical parts that would be too difficult to create. In the final design that I came up with, this one was the one that I decided to go with, that used the ramp design, but also used a rather simple arm to pick up the coin and drop it onto the ramp, where it would slide down and land back on the podium. Some questions that I had when first creating this, though, was what shape would the ramp have to be to make the coin most efficiently fall down and slide onto the podium? Also, would the coin slide too far? I didn't know, because in my original design I didn't have a wall to back it, so I didn't know how far the coin would actually go with the physics involved. And what shape should the arm be? The arm was a design that I came up with originally, but I didn't have a set shape for it yet, and I was considering different possibilities of what would be easiest and most efficient to use with the coin. In the first print, I decided to go for a mix of filament and resin, with the ramp itself being resin in hopes of getting more fine-tuned details. I wanted it to be smooth in hopes that the coin would move across it easily. The arm itself uses filament so that it hopefully keeps its shape and doesn't bend too much or break in the use of the device. The print itself came out rather well. It held the shape that I wanted it to, and the resin did a good job of making the ramp smooth and sloped. The main problem that I found with the resin, however, was that it held too much friction with the coin, so the coin wouldn't slide completely down, and also the print made a small lip at the bottom of the ramp that would keep the coin and oftentimes prevent it from actually making its way onto the podium. The arm, however, I kept for the next few prints, as it seemed to serve its purpose quite well. In the second draft, I swapped out the resin for filament to hopefully remove that friction that was a problem in the first one. In the print, I also raised it up because the last print was a little bit too low, and when the coin did come over the lip of the ramp, it would either hit the podium on the side or not make it all the way up. So I raised up this base to hopefully remove that issue. And in early testing, I found that it did remove a lot of the problems caused by the resin. However, one issue that I began to see was that it would either slide off too much, it would either slide off the podium completely or divert a little to the left or the right and fall off the podium that way. And this video shows some of the early problems that I saw with the design. As you can see, a lot of the times when the coin made its way off the arm, it was inconsistent on where it would land on the ramp, and it was even more consistent of where the coin would go after that. In the end, we decided that this design was a bit too inconsistent for the project at hand, so we decided to swap it off and go with Emarie's idea.
Okay, so this is my first sketch of my design, and we have our main base, and then the part that holds the quarter, and our base connector. And then I also had to get the dimensions of the quarter in order to know where, how the quarter would fit in the holder. So some of the first questions I asked myself was, what dimensions will I need? Because my design is very dimension-based driven. So I need to know the dimensions of the quarter in order for it to be able to fit inside the holder. I needed to know the dimensions of the base connector hole in order for the prongs to be able to fit into there. And I also needed to know the weight of the offset in order to be able to actually flip the quarter. Now, some of the risks that I thought about when printing this was the parts may be too small and too tedious to actually print fully, as these holes were very small, and I eventually would have to tweak these sizes. And also, I was going to try to attempt to print without support, which actually I found successful and to be beneficial in my design. So my first design, I had a couple problems in this first video that I'll show. The weight that I chose at the beginning to offset didn't actually flip the coin. As you can see, however, the lift actually functioned properly and how I wanted to. And another problem I found was the base connectors were not secure enough in the device, which caused it to, when the main base would be lifted up, it would cause the connectors to sometimes pop out of the base, which would cause the whole device to fall apart, which is not something we want. Also, the main quarter holder, the dimensions weren't perfectly exact, which caused the quarter to not always fit in perfectly, which would cause it sometimes to fall off, which did not help in the flipping. So for my next construction, I decided to deepen the quarter holder divot in order to more securely have a hold on the quarter and have a bigger lip for that surface area to touch. And then I increased the base connector size a little bit as well, which I would have to increase again in my next design. And then I also changed my offset weight in order for it to be able to flip and not get stuck like the other one. But with this addition, it ended up to where it was too large to actually go under the main circular holder, which caused it to potentially get stuck. So there wasn't enough space, as you can see, in between that lip. And then also the prongs that were connecting the main circular holder to the connector, one of them broke off, showing that it was not structurally stable and needed to be increased in size. So this led me to my final design, and I'll play just a video first of it working as I kind of explain what I changed. So I first increased the outside ring diameter in order for those weights to be able to make it through in order to flip the quarter so it wouldn't get stuck. I also had to change the base size connector points a little bit more just so they would fit nice and snug. And then I added an extension to the front, which wasn't a necessity, but it was just, I had extra material, so I was able to add it in order for the product to be more efficient for more people and have an easier way of being used. And then this is my overall assembly in Inventor, and that just shows all the parts to get together. And then this is a video of it going around 3 times, and this shows its consistency, and which was some problems we had in previous designs. And as you can see, it always lands back on the X. We never have to worry about where it lands, and it, most of all, flips the coin from being on heads to tails.
And this here is our final design right here, and as you can see, we've made many views to show the different parts of the design. This here, the exploded isometric, is here to help provide each of the parts in how they would operate independently, such as the prongs going in the base, the central ring itself, and the 2 clamps that hold the coin into place. Over here you can see how they all slot together and how the final product looks in a resting form. We have the prongs inside the coin, inside the main ring, and the ring attached to the 2 prongs. Down here we have sketches of the prongs that hold the ring, that hold the coin in place, as well as the 2 prongs that hold the actual device in the base.
Another view that we decided to put on was half sections, and these are important for the design because it's able to show the divot that had to be made and the lip that had to be made in order to hold the quarter, and that would be crucial and necessary to make the design yourself to know that information. And then we also have our main outer ring base, and it shows its basic dimensions in order to construct.
Alright, so this final design that we came up with, we found many pros that the design had over the previous design that I created, as well as some overall pros in general for the design itself. First off, as Emarie said earlier, this print did not require support for being made with resin, which was very beneficial to the overall design and helped with material costs. Also, there was no specific force required to operate the device. This was something that was not present in my design, where varying levels of force applied to the arm would also give varying results. With this design, it was made with the fact that you could apply different amounts of force to the actual ring itself, and the results should be fairly consistent. It should always remain back on the podium and in the same position as it was previously.
Some other pros of my design was it was a simple function, and as I said, with the extended arm that made it easier to use, and so I feel like it could be used between all ages. And then also it was consistent. It worked 100% of the time, and it always landed the quarter in the same spot as John Edwards said. And then it also meets the requirements and follows the restrictions that were stated in the competition requirements. And that concludes our presentation.